Right, here's the unit circle, and I'm hoping that by now you know your way around the unit circle. So just to fill it in, we've got 0 in radians because there's no degrees symbol, pi on 2, pi, and 3 pi on 2. The blue ones are the angles of symmetry with pi on 6, so they're the ones that are close to the x-axis. The red ones right in the middle are the pi on 4s, and the green ones, which are close to the y-axis, are the pi on 3s. So hopefully by now you've learnt the patterns. For the pi on 6s, which are close to the x-axis, we've got 1, 5, 7, and 11. The pi on 4s, which are right in the middle, we've got 1, 3, 5, and 7. And the pi on 3s, which are close to the y-axis, we've got 1, 2, 4, and 5. Okay, so they're not difficult to remember, but it's crucial that you do know instantly which quadrant you're in when you're given an angle in radian measure. So with all of those angles, we can now proceed to find y values in exact form all the way around the unit circle. So it's imperative that you know that unit circle and also that you know your exact values. So I don't care what method you use to memorise these, sine, cos and tan, pi on 6, pi on 4 and pi on 3. So 1 on 2, 1 on root 2, root 3 on 2. Then reversing them, root 3 on 2, 1 on root 2, a half. And then tan is sine divided by cos, so when you do state change flip, the 2's cancel, you get 1 on root 3, 1 and root 3. Okay, so when you're first starting to do these, you might need to have the unit circle and your table of exact values in front of you until you've memorised them. So do some look, say, cover right check until you've memorised both of those. And once you've memorised them, you can start to do exact values without having to refer back to your notes. Okay, so just keep it there until you get the hang of it and then get rid of it once you've learnt it all. So let's have a look at how we're going to use the unit circle and these exact values to help us do something to do with circular functions. So if we have a look at, I've got a couple of examples coming up. Okay, here we go. So if you're asked to find sine of pi on 6, okay, now you see at the beginning, at the top of the board, it says finding y coordinates. Okay, we're going to come back to that in a minute because at the moment we're just looking at the algebra without considering the graph. So if we're asked to find sine of 7 pi on 6, there are 3 questions we need to ask ourselves. First of all, we need to know where we are. Where are we around the unit circle? Okay, in terms of which quadrant. So then the second question you have to ask yourself is it positive or negative? And then the third question is, what's the exact value from the table of exact values? So 3 questions you have to be asking yourself. Sine of 7 pi on 6. So you need to know, first of all, where you are. 7 pi on 6 is in the third quadrant. Is it positive or negative? Well, in the third quadrant, sine is negative. So we know that our answer is going to be negative. And then we look at the denominator. So ignoring the 7 pi on the top, but sine of pi on 6 from our table of exact values is a half. And that's it, we've got our answer. So sine of 7 pi on 6, it was in the third quadrant where sine is negative, and from the table of exact values, sine of pi on 6 is a half. So that's our answer. Let's do another one, cos of 7 pi on 4. Where are we? 7 pi on 4, we are in the fourth quadrant. Is cos negative or positive? It's positive. And from the table of exact values, what's cos of pi on 4? 1 on root 2. And that's all we need to do. Okay, now these questions are probably only 1 markers. You don't really need to show much working at all. In fact, I haven't shown any working. If you feel uncomfortable with that and you want to do something, perhaps you can just have which quadrant you're in. So 7 pi on 6, you know that it was that angle there that was close to the x-axis, so you know you're in the third quadrant. Similarly, for cos of 7 pi on 4, it's right in the middle of the fourth quadrant where cos is positive. Let's have a look at this tan one. Just ignore the negative at first and look at tan of 2 pi on 3. So 2 pi on 3, where am I? I'm in the second quadrant. Is tan positive or negative? It's negative. From the table of exact values, tan of pi on 3 is root 3. So tan of 2 pi on 3 we know is negative root 3, but we wanted the negative of that, so our answer is positive root 3. Okay, and it was there, up close to the y-axis. Let's do a couple more until you've got the hang of it. What about sine of 5 pi on 3? Which quadrant am I in? I'm in the fourth quadrant. Sine is positive or negative? It's negative, and from the table of exact values, sine of pi on 3 is root 3 on 2. Another one. Cos of 3 pi on 4. Where am I? Second quadrant. Positive or negative? Negative. Cos of pi on 4, 1 on root 2. Once you've memorised your unit circle in the table of exact values, these are really easy. One more to finish up, another tan one. Tan of 4 pi on 3. Where am I? Third quadrant. Positive or negative? Positive. Tan of pi on 3, and we've got root 3. Okay, so what does all this mean? It's not enough to just be able to find the exact value given this sine 7 pi on 6 or whatever. You have to understand what it all means. The instruction at the top said finding y coordinates. So if we're looking, for example, at the graph of sine x, so I'm going to just consider sine x for a minute, where y equals sine x. Well, sine of 7 pi on 6 means that we've substituted x equals 7 pi on 6 into that equation. So where x equals 7 pi on 6. Okay, so now it's important to make the connection between what we've been doing using algebra and the graph. So let's have a look at sine of sine x, the graph of sine x. So I'm going to enter it here. So sine x. Okay, so we need to adjust the window a bit. I'm going to look at the window between 0 and 2 pi. And I'm going to do a zoom fit just so that it's a bit bigger and a bit easier to work with. Okay, so I'll move that out the way. Alright, so something you might not know how to do is if you double click on that text there, you can change that to anything you like. I'm going to change it to pi on 2. And you can see that it has adjusted the scale for me, and I've now got the increments all marked there. Unfortunately, the board's made the 2 pi bit just go off the board slightly, but it doesn't matter, we've got the bulk of the graph there to look at. Okay, so let's make this connection now between our exact values and what's going on the graph. The first thing I want to do is look at that exact value of a half. So when sine of pi on 6 equals a half. Well, what does that mean? We know the amplitude here is 1. So when y equals a half, I'm going to pop that line in. So if y equals a half, you can see with that green line there that the graph of sine x is going to cut y equals a half in two places. And those places correspond to angles of symmetry with pi on 6. So that first one is pi on 6. How do I know for sure? Well, I'm going to put a point on. So, points and lines, point on. I'm going to put a point on the graph on this one here. So double click, just escape that, and then I can change that value there to pi on 6. And there you see it coincides with that point of intersection. So there's a couple of little skills there that you might not be aware of. So now with that point on, I can change that x value anytime I want, and the point will move to the point that I've assigned it to. So pi on 6 has a y coordinate of a half. So when you do sine of pi on 6 equals a half, what you've actually found is the y coordinate on that graph sine x? So we've got that other point over here, the second point of intersection, and you can see that it is close to pi, and we know from the symmetry of the unit circle that it is 5 pi on 6. So I'm just going to change that value there, and so when it says text you can double click on it. There we go. When it highlights, I'm going to change that to 5 pi on 6, and it should move over to the second point of intersection, and there it is. Okay, so when y equals a half, x equals either pi on 6 or 5 pi on 6. So we're making this connection between x and y values and the table of exact values and the unit circle by looking at the graph. Now, in our table of exact values for sine, we've also got 1 on root 2 and root 3 on 2. Now, I think it's important to know what those answers are in approximate form. So I'm just going to go to a calculator page, and I'm going to enter 1 on root 2. 1 on root 2, and find, well, that's approximately 0.7. And what about root 3 on 2? Root 3 on 2 is approximately 0.9, just to make it easy to one decimal place. So 0.7 and 0.9. So let's go back to the graph here. So 0.7 is moving to the right of that first point of intersection, and 0.9 is getting quite close to the maximum value there. So when we talk about the sine of pi on 6, pi on 4 and pi on 3, what we're doing is we're looking at those y values as we move along this curve, changing from pi on 6, moving to the right to pi on 4, and then to pi on 3. So let's put in pi on 4. Now we know that sine of pi on 4 is 1 on root 2, which was approximately 0.7. So when I press enter, this point should move to the curve where it's about 0.7. So you can look at your y-axis, and it's going to be two and a bit units higher than that green line. So when I press enter, let's see where it goes. And there it is, halfway between 0 and 2 pi. Halfway between 0 and pi on 2, we've got pi on 4, and there it is, that y coordinate. And then when I change it to pi on 3, it should move a bit more to the right, pi on 3, because we know that sine of pi on 3 is approximately 0.9. And there it is. I might just go back to that for a second, just in case you haven't covered this as well. When you get that exact value, pi on 4, the corresponding y coordinate is root 2 on 2. Just in case you haven't had that explained to you, that's just the rationalised form of 1 on root 2. In methods, you're not expected to rationalise your denominator, but you are expected to recognise that root 2 on 2 is the same as 1 on root 2. Okay, so let's go back to our table of exact values. Okay, so with the table of exact values, what you're actually saying is that in exact form, when x equals pi on 6 on the graph of sine x, the y coordinate will be a half. When x equals pi on 4, the y coordinate will be approximately 0.7, and so on and so forth. So it's really important that you have that connection between the algebra that you're doing and also the graph.